All right. Hello, everybody. Welcome to section 1.7. We're going to talk about inverse functions. So here, this is kind of a picture that's kind of meant to show you how a function works and then compare it to how an inverse works. So a function is kind of like a machine. And I remember years ago, I was actually teaching some students at a high school about functions, and they were getting all excited. They're like, we're gonna have like a machine? And I kind of disappointed them. It's like, no, we don't actually have a machine we're doing this with. But then they asked me, like, is there something that's a function machine? I said, yes, there is. It's called a computer. That's what they do nonstop all day long. They are just super hyper advanced, overpowered calculators, is really all they are. But anyway, what is a function? You take a number, an input x, you dump it into the function, it does stuff. It could add 2, it could do all sorts of more complicated things. But you put in a number, it does stuff, and then it spits out a number. And the idea of an inverse is it's just something that will do that process in reverse. Because the goal in mathematics is that anytime you do an action, you want to be able to undo that action and go back to what you had before. Anyone who's ever had to use like the undo command in like Microsoft Word or something is probably familiar with this concept that you do something and then you need to undo it for reasons. But anyway, that's the big idea for an inverse function. So, with a function, you put in x, you get out a y. If you turn right around, you put in a y, it spits out an x. And what it will do is it will basically get you back to where you started. And it undoes another function. This is basically to undo an action. That's the idea of an inverse. It undoes an action that a different function does. So here's kind of a more gobbledygook mouthful definition of what a function is. So for any one-to-one function, f of x equals y, a function f negative 1 of x is an inverse function. F negative 1 of x, that's something, by the way, you're going to want to get really used to, because that's the way that's sort of the name given to inverse functions. You put the little negative 1 up there, and that symbol means inverse function. So that will be an inverse if f negative 1 spits out x. So this is basically, you put y into the inverse and gets x, and that undoes if you put x into the function and get y. With composition, we talked about composition. If you compose a function and its inverse together, they're gonna cancel each other out basically and spit back out the original number. That's what I was getting at earlier when I was saying it undoes an action. So f negative 1 is read f inverse. So if you're reading that on a page, that's like how you would say it. This is not the same. This is something else. F negative 1 is not saying like take the function and do the reciprocal of it. That's not what this means. It may look like that because if you do the negative 1 power, that is what the negative 1 power does in most normal situations, but that is not what it means. Fun fact, not all functions have inverses. We talked earlier about having to be a one-to-one function. If you're not one-to-one, you don't have an inverse. You have to mess with it in some fashion to get an inverse, to be able to have an inverse. Okay. For a particular one-to-one function, f of 2 is 4 and f of 5 is 12. What are the corresponding input and output values for the inverse function? So basically what that means, the input is x and the output is y. Here's another x, here's another y. So the number that goes in, the number that's in the parentheses, that's what you put into the function. If you want the inverse function, what we could say is this. F negative 1 of the number 4, so we start on the other end. If we do the inverse of 4, what would that spit out? It would spit out the 2 that we started with originally. Meanwhile, here, F inverse of 12, which is the output, that would spit out 5. So that's really all they're going for. The wording may make it seem like it's way more complicated than that, but that's all this is. That's all that means. If you put in 2, you get 4. So then if you're going backwards, start at 4, that came from 2. If you put in 5, you get 12. So if you go backwards, 12 came from 5. It's just the reverse of that. Okay. So here they say f of x equals x to the third minus 4. G of x is the third root of x plus 4. Is G f inverse? Well, how would we test that? Well, what you can do is you can say, okay, if I compose these with each other, so if I do f of g of x, so we did this sort of thing earlier, that means we're going to take the f function, which is to take something, raise it to the third power, then subtract 4. That's what f does. What's going to go inside it, and maybe I'll do G in blue here and color code them. So G of x goes inside f of x. What is G of x? It is the third root of x plus 4. Now, if all goes well, if you compose a function with its inverse, it should give you x. That's the definition here. So f of f inverse of x, if you compose those, you get x, if you put the one inside the other. Now, if you do a third root to the third power, guess what happens? That's just x plus 4, because the third root will cancel out the third power. So then what's left is x plus 4 minus 4. Fun fact, plus 4 minus 4 will cancel out. So that leaves you with x. So f of g of x equaled x. So then the answer is yes, g of x equals f inverse, or I guess g equals f inverse. You could put the x's on there if you wanted to, but they didn't originally, so, but anyway. The answer is yes. If you do composition with one function and another function, if all that's left is x, then that means they are inverses. So the domain and range of inverse functions. So the range of a function, let's see, the range of a function f of x is the domain of the inverse function, and then the domain of f of x is the range of f inverse of x. So with this picture, basically what they're showing you here, for f of x, you start from there and go there. Where you start is the domain, where you end is the range. So that's the domain of f and the range of f. If you go in reverse, the inverse, you're going to go that direction. So then the range of f is the domain of f inverse, and the range of f inverse is the domain of the original function. So you're basically going backwards. The range is like where you ended up. You turn right around, that becomes the new domain of the inverse, and it sends you back to where you came from. So sometimes the domain of the original function needs to be restricted to make it one-to-one. That can happen sometimes. You've probably seen this before without realizing it, but to make y equals square root of x 1-to-1, we limit x to non-negative numbers. So you have actually, probably without realizing it, encountered this idea before, but like the reason you can't put negative numbers into a square root function is that you have to basically lop off part of a square graph in order to make it so that it's one-to-one. This would be what y equals x squared is. It's going to fail the horizontal line test. So it's not one-to-one. So you've actually encountered a version of this idea already, and that's all they're talking about. It's just that some functions are not going to be one-to-one. So to fix that problem so that the inverse only gives one value, you basically limit the domain to make it one-to-one. So essentially what they do to solve this problem is they kind of sort of lop off this half and only let you do square roots of the positive numbers and not the negative numbers. Okay. The domain of function f is 1 to infinity. The range of function f is negative infinity to negative 2. Find the domain and range of the inverse function, okay? So we'll do the domain of f inverse it's basically going to be what was originally the range. So negative infinity to negative 2. That is now the domain. The range of f inverse, what was originally the domain, becomes the range, 1 to infinity. So the punchline here, the big takeaway, domain and range switch places. In very, very simple terms, that's what's happening. Okay. So next up, what we have, given a function with a formula, how to find the inverse. So first you want to make sure that it's 1-to-1. Then you solve for x, and then you need to interchange x and y. So when they say interchange x and y, that kind of touches on what we were just talking about. X and y switch places. So when we say the domain and range switch places, all the x's are the domain, all the y's are the range. So if we're switching the domain and the range, that means we're switching x and y. So in terms of the formula, how would we do that? So we got this formula right here. So they say solve for x in terms of y given this. So we're going to say y equals 1/3 x minus 5. Let me just check something here. So what we're going to do is we're going to swap places with x and y. So we're going to say, okay, x equals 1/3 y minus 5. And then what we're going to do, if you want to get rid of 1/3, you need to multiply both sides by 3. I will get rid of the 1/3 for you. So then 3x equals y minus 5. Since you're subtracting 5, you would then need to add 5. So that basically means f of x is what we started with, 1/3 times x minus 5. And then f inverse of x is that right there, 3x plus 5. So we have found the inverse function, 3 times x plus 5. Okay. What is the inverse of the function f of x equals 2 minus square root of x? State the domains of both the function and the inverse function. Okay, so this, you can't put a negative number inside a square root. So the domain of f that is going to be so the x has to be greater than or equal to 0. Or if you wrote that as an interval, it would be from 0 to infinity. That's two slightly different ways of writing it. That's the domain of f of x. So then, what we're going to do is for f inverse, we're going to say, all right, y equals 2 minus root of x. To find the inverse, what we will do is we will switch places of the x and the y, which means we're going to say x equals 2 minus square root y. We then need to solve this for y. So what we will do is, let's see here. Let's subtract 2 from both sides. That's going to give you x minus 2 equals negative root y. We would then need to divide by -1 to get rid of the negative sign. So if we do that, we're going to get square root of y equals negative x plus 2. We're going to just change the signs around basically. And then what we need to do to solve this is we need to square both sides. And so that's going to give me y equals negative x plus 2 quantity squared. Then they want the domain of the inverse function. And so actually, hold on. I should really write this as an inverse. So f inverse of x equals negative x plus 2 squared. So that is the inverse function. And then you look at this and you say, okay, the domain of this. We talked about the two limits on the domain. You can't divide by 0. Well, there's no division happening here, so we don't have to worry about that. The other thing is that you can't square root negative numbers. Our inverse also doesn't have a square root. So there are no limits on the domain because there's no square rooting happening. There's no division happening. So the domain for this is actually going to go from negative infinity to positive infinity. That's the domain of f inverse of x. So we have the domain of f of x and we have the domain of f inverse. Solving to find an inverse function. So find the inverse of the function 2 over x minus 3 plus 4. So what we're going to do is we need to find the inverse of that. So y equals 2 over x minus 3 plus 4. So what we're going to do is we're going to transpose x and y. X equals 2 over y minus 3 plus 4. All right, so what would we do first? Well, since we're adding 4, let's subtract 4, shall we? That's going to give me x minus 4 equals 2 over y minus 3. I have put those in parentheses just because I'm going to lock in these two things here together. Since I'm dividing y minus 3, the way to get rid of that is to multiply y minus 3. And we're going to multiply y minus 3 here. You might be tempted to do FOIL with that, but we're actually not going to do that because we're trying to solve for the y. So we're actually going to get rid of that a different way. So resist the temptation to like FOIL that out because it's just going to make it more complicated than it needs to be. Now we're multiplying this thing in parentheses x minus 4. So the way to get rid of that is to divide x minus 4. So basically what ends up happening is that the x part and the y part end up trading places here. Y minus 3 equals 2 all over x minus 4. And the last thing you would need to do, since you're subtracting 3, is you would need to add 3. And kind of like what our function looked like originally, we're just going to have something like this. Y equals 2 over x minus 4 plus 3. And so then f inverse of x, that's this formula right here. It's 2 over x minus 4 plus 3. All right, I'll graph those in a minute, but I'll kind of leave that up there for a second, just in case anyone's playing catch up here. But that is finding the inverse function. So the last thing that we'll leave with for this particular section is we'll talk about the graph of a function and its inverse. And that'll be kind of the last thing that we mention. So and I'll tell you what, here's what I will do. So this is an online graphing calculator that will be a little easier to work with than going back and forth with the handheld calculator. But what do we got? So we're going to do, what was the original equation here? It was 2 divided by x plus 3 all and then plus 4. So what we're going to do is we're going to do 2 divided by and then parentheses x plus 3. Let me just check. Was it x plus 3 or was it minus? X minus 3 and then a plus 4. So this is x minus 3. The thing I just want you to notice is that when I do the fraction like that, I put the stuff on bottom in parentheses just so that the calculator will recognize the fact that the x minus 3 all together is what's being divided there. And if you type it in like with a TI-84, it'll be the same idea. You want to do 2 divided by parentheses x minus 3. And then you close the parentheses and put the plus 4 after it. What did we get for the inverse? 2 over x minus 4 plus 3. Okay, so y equals 2. Or what was it? 2, was it? Okay, it was 2. 2 over x minus 4 plus 3. Okay. So 2 divided by x minus 4 and then arrow over plus 3. Okay, so you kind of get this wacky looking pair of graphs. Okay, well, isn't that interesting? Here's the punchline. I'm going to graph the line y equals x. The reason I'm graphing y equals x is because if you switch x and y, that's another way of saying y equals x. Yes, if they're allowed to trade places, that's another way of saying y equals x, which is that line right there. It has an intercept of 0, it has a slope of 1, and it's that diagonal line right there. Here's the punchline. So the red graph, if you flip it like diagonally over the green line, it will turn into the blue graph. That's like the punchline, the takeaway from this. So what I will do, I will use my super rad technology skills and just do a screen grab of this graph. Come on, we're being slow, computer. All right, so here's what we'll do. So we'll do a screen grab of this picture. And then we will copy this and just put it in the notes because I am technologically savvy like that. Come on, there we go. That's a little on the big side. All right, so anyway, the punchline, the takeaway from this, which I kind of said, but just to emphasize it, I will write it down. A function and its inverse, or let's see, a function is the reflection of its inverse over the line y equals x. So that's sort of the punchline or the big takeaway for this. if you graph a function and its inverse, they will be mirror images of each other across that diagonal line. And one last thing I will leave you with, because I kind of sort of mentioned this, to look at like a simpler example of this phenomenon. Let's say we were to graph y equals x squared. And then let's also graph y equals the square root of x. And then maybe what I will also do for good measure is I will graph y equals the negative square root of x. And so here what you will notice, the red graph is a garden variety parabola. The square root is its inverse. And if you flip it over the green line, you obtain the blue and purple graphs together. Now, because the x squared graph is not one-to-one, how they kind of make the square root graph a function is they basically lop off the bottom half. And then that way, when they graph the inverse, you get something that is itself a function. Because if you flip over the whole thing, you end up with this kind of sideways U graph. And if you put a vertical line there, it will fail the vertical line test and not be a function. So basically the solution is they kind of lop off the bottom half of the parabola and say, okay, that's the square root graph. But it's no accident that the square root graph is half of a flipped over parabola. Okay, so that is the end of that section. So let's stop there for now.